In 1990, Carl Sagan convinced NASA to do something that seemed pointless to many engineers. He asked them to turn the Voyager 1 spacecraft around 4 billion miles from Earth to take one last photograph of home. What came back changed how we understand our place in the universe. That image, a single pale blue pixel suspended in a sunbeam, revealed something most people still get wrong about what it means to exist in a cosmos this vast. They see insignificance where they should see something far more interesting. I want to take you on a journey through time, through what I call the great demotions, the series of discoveries that stripped away our comfortable illusions about being central and special, and revealed something more profound and more beautiful than any story we told ourselves when we thought we occupied the center of everything. Look up tonight if you can, find a dark place away from the city lights, and look up at the thousands of stars scattered across the blackness. Beautiful and humbling, yes, but almost everything most people think they understand about what they're seeing is fundamentally wrong. Humans spent most of our history looking at that same sky and reaching a reasonable conclusion that we sat at the center of everything. The sun rose and set around us, the stars wheeled overhead in stately procession, and it all seemed so obvious that this whole cosmic show was arranged for our benefit. 500 years of discovery have been demolishing that comfortable, flattering idea. And in the Cosmos television series, I trace these humiliations of our species with something like affection, because what rose in their place turned out to be far more interesting than what we lost. The obvious truth for thousands of years was that Earth sat motionless at the center of the universe, while the sun, moon, planets, and stars all revolved around us in crystalline spheres. This wasn't arrogance, but observation, because you can feel that the ground beneath your feet isn't moving, and you can see the sun trace its arc across the sky. Aristotle and Ptolemy codified this view, and it dominated Western thought for nearly 2 millennia. Copernicus delivered our first great demotion when he proposed that Earth is not the center, but instead orbits the sun like all the other planets. He published this idea on his deathbed in 1543, perhaps knowing the trouble it would cause. Galileo Galilei turned his telescope toward Jupiter and saw moons orbiting another world, direct evidence that not everything revolved around Earth. For supporting the Copernican view, the Roman Inquisition placed Galileo under house arrest for the final 9 years of his life. The crime of showing humanity its true position carried a heavy sentence. This disturbed many people who wondered how we could be important if we're not at the center. At least the sun held the center. At least our star was still something special. But then we discovered that the sun is just one star among the multitudes we see at night, and not a particularly remarkable one at that. A middle-aged, medium-sized, yellow dwarf star, sitting in the Orion arm of the Milky Way, roughly two-thirds of the way out from the galactic center, unremarkable in almost every measurable way. There are stars far larger, far hotter, far more energetic, and our sun is lost in their crowd like a single grain of sand on a vast beach. Another demotion came from geologists and physicists with their radiometric dating. In the 19th century, Lord Kelvin calculated the Earth was perhaps 20 million years old based on cooling rates. He was wrong by a factor of 200. The Earth is 4.5 billion years old, and the universe itself nearly 14 billion. Humanity's entire existence, every cave painting, every bronze sword, every cathedral, every spacecraft, all of it fits into a sliver of time so thin you could barely see it on any honest timeline. We are newcomers who arrived at the party when it was already 14 billion years underway. Darwin delivered perhaps the most personal demotion of all when he showed we weren't special creations but products of the same natural processes that produced every other living thing on Earth. We share ancestors with apes, with mice, with trees, with the bacteria in your gut. The molecular structure of human DNA is 98.6% identical to that of chimpanzees. Man in his arrogance thinks himself a great work worthy of the interposition of a deity, Darwin noted. But more humble and more true is considering him created from animals. Many clung to one final hope, that surely we are alone, that even if we aren't central, even if we aren't old, even if we're made by the same processes as slime molds, at least we are the only intelligence in the universe. In 1950, the physicist Enrico Fermi asked a simple question over lunch at Los Alamos. Where is everybody? If the universe is so vast and so old, and if life arises naturally, then intelligent civilizations should have emerged millions or billions of years before us. They should have colonized the galaxy by now. We should see their works everywhere, but we don't. This is the Fermi paradox, and we still don't know the answer. My colleague Frank Drake developed an equation to estimate the number of communicating civilizations in our galaxy. The Drake equation multiplies together factors like the rate of star formation, the fraction of stars with planets, the fraction of planets where life develops, and so on. Reasonable estimates suggest there should be thousands or millions of such civilizations. Yet, our radio telescopes hear only silence, and the search for extraterrestrial intelligence, SETI, has found no confirmed signals in over 6 decades of listening. Perhaps intelligence is rarer than we thought. Perhaps civilizations destroy themselves before they can reach the stars. Perhaps they're out there, but we don't recognize their communications. We don't yet know the answer, but the numbers argue strongly against our uniqueness. The immensity of the cosmos, the ubiquity of the chemical elements necessary for life, and the billions of years available for evolution on countless worlds make it far more likely that the universe is brimming over with life than that we are alone. Edwin Hubble pointed the 100-inch Hooker telescope at Mount Wilson Observatory toward fuzzy patches of light and discovered they weren't clouds of gas within our galaxy, but other galaxies entirely, islands of hundreds of billions of stars separated from us by millions of light years of nearly empty space. The Milky Way wasn't the universe, but one galaxy among what we now know to be at least 200 billion galaxies, each with hundreds of billions of stars, each star potentially hosting worlds. Stop and think about that for a moment. The James Webb Space Telescope, launched in 2021 and stationed 1 million miles from Earth, has revealed galaxies forming just a few 100 million years after the Big Bang, earlier than we thought possible. It has detected water vapor in the atmospheres of rocky exoplanets, worlds like TRAPPIST-1e and K218b that orbit in the habitable zones of their stars. We are beginning to photograph other pale blue dots. As of now, astronomers have confirmed more than 5,500 exoplanets, with thousands more candidates awaiting verification. 10 billion trillion worlds may exist in all the galaxies we can see. In the face of such overpowering numbers, what is the likelihood that only one ordinary star, the Sun, is accompanied by an inhabited planet? Why should we, tucked away in some forgotten corner of the cosmos, be so fortunate as to be the only ones? We inhabit a universe where atoms are made in the centers of stars, where each second 1,000 suns are born, where life is sparked by sunlight and lightning in the airs and waters of youthful planets. The raw material for biological evolution is sometimes made by the explosion of a star halfway across the Milky Way. The thing as beautiful as a galaxy is formed 100 billion times, a cosmos of quasars and quarks, snowflakes and fireflies, where there may be black holes and other universes and extraterrestrial civilizations whose radio messages are at this moment reaching the Earth. How pallid by comparison are the pretensions of superstition and pseudoscience, and how important it is for us to pursue and understand science, that characteristically human endeavor. And this brings us to what most people get wrong. The common reaction to all of this is despair. We look at the immensity of the cosmos, the countless galaxies, the unimaginable spans of space and time, and we feel crushed by our own insignificance. We were promised we were special, the center, the purpose, the crown of creation, and now we learn we're on a tiny rock orbiting an ordinary star in the suburbs of an unremarkable galaxy, one mote among countless motes. This is where most people stop. The story gets told over and over. We used to think we were important, and now we know we're not. End of story. It's a cold universe. We're a meaningless accident. Nothing matters. But this conclusion, this despair, represents a profound failure of imagination. It gets the science right, but misses the deeper truth entirely. Think about what that means when we consider that, yes, we are small. The Earth is a very small stage in a vast cosmic arena. Think of the rivers of blood spilled by all those generals and emperors so that in glory and triumph they could become the momentary masters of a fraction of a dot. Think of the endless cruelties visited by the inhabitants of one corner of this pixel on the scarcely distinguishable inhabitants of some other corner. How frequent their misunderstandings, how eager they are to kill one another, how fervent their hatreds. Our posturings, our imagined self-importance, the delusion that we have some privileged position in the universe, these are challenged by this point of pale light. But challenged is not the same as refuted. And insignificance in one sense does not mean insignificance in every sense. Here is what the great demotions actually teach us if we pay attention. If you wish to make an apple pie from scratch, you must first invent the universe. I mean that literally. Every ingredient in that apple pie, the flour, the sugar, the apples themselves, is made of atoms that were not always here. In the beginning, just after the Big Bang, the universe contained only the simplest elements: hydrogen, helium, and traces of lithium. Nothing else. No carbon, no oxygen, no iron, no silicon, just the lightest elements forged in the first few minutes of cosmic time. Where did all the other elements come from? The carbon in the flower, the oxygen in the apples, the calcium and iron and phosphorus, they were made in stars. Deep in the hearts of massive stars, under temperatures and pressures we can barely imagine, hydrogen atoms are squeezed together to form helium while the star burns with nuclear fire, converting its substance from one element to another. Helium fuses into carbon, carbon into oxygen, oxygen into neon, and the nuclear alchemy continues, building heavier and heavier elements in layers like an onion until the star can fuse no more. And that's when, in some stars, the massive ones, the giants, comes the supernova. A cataclysmic explosion of almost unimaginable violence releases more energy than our sun will produce in its entire 10 billion year lifetime. In that explosion, and in the intense fires leading up to it, the heaviest elements are forged and scattered across interstellar space. The nitrogen in our DNA, the calcium in our teeth, the iron in our blood, the carbon in our apple pies, all of it was made in the interiors of collapsing stars. We are made of star stuff, but I can be more specific than that now. Astronomers have developed a field called galactic archaeology, tracing the chemical signatures of stars to understand their origins. The specific iron atoms in your blood likely formed in a Type II supernova approximately 5 billion years ago, before our sun even existed. Some of these stellar nurseries were in what is now the Orion Nebula, visible on winter nights as a fuzzy patch in the sword of the constellation. Your body is an archaeological site, and the artifacts it contains are older than the Earth. Our bodies contain 3 grams of iron, 3 grams of bright silver white magnesium, and smaller amounts of manganese and copper. Proportionate to size, these are among the weightiest atoms in our bodies. They come from the same source, a long ago star that exploded before our sun was born, seeding the cloud of gas and dust from which our solar system formed. When you look at your hand, you are looking at recycled stellar debris. The atoms that make up your skin, your bones, your brain were cooked in a furnace millions of times hotter than any oven, in a cauldron larger than worlds, in a star that exploded when the Earth was young, or perhaps before the Earth existed at all. Some of the atoms in your left hand probably came from a different star than the atoms in your right hand. Because we are assembled from the remnants of multiple stellar deaths, the universe took billions of years and the destruction of countless suns to make you. We are made of star stuff. Think about what that means. You are not merely in the universe, not a passive observer looking out at the cosmos from some separate vantage point. The cosmos is within you. The atoms in your body are ancient, billions of years old, having been part of countless cosmic processes, once inside a star. We are a way for the universe to know itself. This should restructure how you see everything. You are not an accident occurring in an indifferent universe, but the universe experiencing itself. Through you, through your eyes, your mind, your curiosity, hydrogen atoms that formed in the first minutes after the Big Bang have evolved to the point where they can contemplate their own origins. In the deepest sense, the universe is looking at itself through you. But let me press this further, because there's another dimension to our place in the cosmos that most people miss entirely, our place in time. Imagine we compress the entire history of the universe into a single year, a cosmic calendar where the Big Bang happens at midnight on January 1st and the present moment is midnight on December 31st. Every second of this calendar corresponds to about 434 years of real time. On this scale, our Milky Way galaxy doesn't form until sometime in May. The Sun and Earth appear in early September. Life begins on Earth around September 14th, but it's single-celled life, simple and small. For months on this calendar, nothing more complex than bacteria exists. The first dinosaurs appear on Christmas Eve, dominating the Earth for the equivalent of a cosmic week before going extinct around 12:59 p.m. on December 30th, just yesterday on our cosmic calendar. And humans, we show up around 10:30 p.m. on December 31st. The entire history of human civilization, every pharaoh, every empire, every war, every invention, every work of art, every scientific discovery, all of it fits into the last few seconds before midnight. Jesus was born about 5 seconds ago on this calendar. Moses, about 7 seconds. The pyramids were built about 11 seconds ago. The beginning of writing, the moment humans first scratched symbols to record their thoughts, that was about 15 seconds ago. Every person you've ever heard of lived in those final seconds. Alexander the Great, Julius Caesar, Cleopatra, Shakespeare, Newton, Einstein, all of them flickered into and out of existence in less time than it takes to say their names measured against the cosmic calendar. All of recorded history is a blink. The rise and fall of Rome, the Renaissance, the scientific revolution, the industrial revolution, the moon landing, all happened in the last second of the cosmic year. And here's something that should humble anyone who claims human beings are the purpose of creation. For the first 3 quarters of that cosmic year, Earth didn't even exist. For most of September, October, November, and half of December, nothing lived here except single-celled organisms. Complex life didn't appear until about 2 weeks ago on this calendar. Dinosaurs ruled for about a week, and we've been here for less than an hour. If the cosmos were made for us, it seems to have taken its time getting around to the point. Now, here's what most people get wrong about this. The common reaction is to feel even smaller, even more insignificant. We're not only tiny in space, a mote of dust in the cosmic ocean, but we're also latecomers in time. The universe got along fine without us. For 13.8 billion years, we just showed up. But consider the alternative perspective. We are incredibly young. As a species, we've been here for the blink of an eye. Yet in that blink, we've gone from chipping rocks into hand axes to landing spacecraft on other worlds. We've decoded the structure of DNA, split the atom, and looked back in time to the cosmic microwave background, the faint afterglow of the Big Bang itself. There's another way to look at our late arrival. If someone from a small village became an acclaimed scientist and made profound discoveries about the nature of the universe, would we dismiss their achievements because they came from a small village? Would their insights be less true because of where they began? The size of your home does not determine the size of your mind, and the fact that we live on a small planet does not diminish what we have learned or what we might yet learn about the cosmos. In fact, our late arrival may be precisely the point. The universe required nearly 14 billion years to create the conditions for minds like ours to exist. That long to make the heavy elements we're composed of, to cook them in stars and scatter them across space. That long to form rocky planets in habitable zones around stable stars. That long for life to arise and evolve and eventually produce creatures capable of wondering where they came from. Some scientists, notably Peter Ward and Donald Brownlee in their rare earth hypothesis, argue that this combination of factors may be extraordinarily uncommon. Complex life may require not just a habitable planet, but a large moon to stabilize axial tilt, a Jupiter-sized planet to sweep away asteroids, a location in the galactic habitable zone away from deadly radiation, and a host of other factors that may align only rarely. If they're right, we may be more precious than we know, but the cosmic calendar has a future too, and no one talks about that. If we survive the next cosmic second, roughly 434 years, we will likely become a multi-planetary species. SpaceX and NASA's Artemis program are working towards sustained human presence on Mars within decades. In the next cosmic minute, perhaps 26,000 years, we might reach nearby stars. The Alpha Centauri system is only 4 light years away. The question isn't whether the universe will continue without us, but whether we'll still be here to witness the next cosmic hour. We are not latecomers to a dying universe, but early risers in a cosmos that has billions of years of future ahead of it. We are children just beginning to ask the big questions, just beginning to explore. What will we know in 1,000 years? A million? A billion? The sun will not die for another 5 billion years, and barring self-destruction, we have time, more time than we can imagine, to grow and learn and explore. Our journey has barely begun. And this brings me to the deepest truth about our place in the universe, the one that ties everything together. The surface of the Earth is the shore of the cosmic ocean. From it, we have learned most of what we know. Recently, we have waded a little way out to sea, enough to dampen our toes or at most wet our ankles. The water seems inviting. The ocean calls. Some part of our being knows this is from where we came. We long to return. This metaphor, the cosmic ocean, runs deep in our history. The ancient Egyptians and Greeks imagined the sky as a kind of celestial sea, and in a way, they were right. We are afloat in an immensity of space and time, surrounded by the productions of nature laboring for aeons. In Alexandria, during the 600 years beginning around 300 BC, human beings, in an important sense, began the intellectual adventure that has led us to the shores of space. The great library there contained perhaps 500,000 scrolls, the accumulated knowledge of the ancient world. Scholars came from every nation to study and debate and push the boundaries of what was known. Eratosthenes, the library's chief librarian, calculated the circumference of the Earth using nothing but shadows and geometry, getting the answer right to within a few percent. Aristarchus proposed that the Earth orbited the Sun 17 centuries before Copernicus. Euclid codified geometry. Archimedes laid foundations for calculus. Hypatia, one of the last great scholars of Alexandria, taught mathematics and astronomy and philosophy until she was murdered by a Christian mob in 415 AD, her flesh scraped from her bones with oyster shells. The library was destroyed in stages by fire, by neglect, by religious zealots, by political violence. The knowledge was scattered and lost. Civilization took a step backward from which it would not fully recover for 1,000 years. We call it the Dark Ages for a reason. We must never let that happen again. But we face our own Alexandria moment. Consider this: 90% of the world's data was created in the last 2 years, stored on servers that could be wiped by a single powerful solar flare, a Carrington event like the one that struck in 1859. The internet feels permanent, but it's more fragile than papyrus. Digital formats become obsolete. Companies go bankrupt. Links rot. Are we building a library or a sandcastle? The cosmos took billions of years to create minds that could understand it. We would be cosmic tragedies if we let that understanding slip away, whether through violence or carelessness. We are the universe's greatest achievement, not because we are central, not because we are old, but because we are aware. The atoms in your brain are engaged in contemplating their own existence. The star stuff that makes up your body is asking questions about stars. And we would be cosmic tragedies if we destroyed ourselves now, just as we're beginning to understand who and where we are. Exploration is in our nature. We began as wanderers, and we are wanderers still. For all our failings, despite our limitations and fallibilities, we humans are capable of greatness. Consider what we've done in the cosmic blink of an eye since we developed science. We've discovered that the universe is not eternal, but began in an unimaginably hot, dense state and has been expanding ever since. We've learned that we share a common ancestor with every living thing on Earth, that the tree outside your window is a distant cousin. We've sent robot emissaries to every planet in our solar system and beyond. Think about the Voyager spacecraft, two small machines launched in 1977, now sailing into interstellar space as the first human-made objects to leave our solar system. Each one carries a golden record, a message in a bottle cast into the cosmic ocean, containing images and sounds from Earth. Music, greetings in 55 languages, the sound of a kiss, a mother's first words to her newborn child, the brainwaves of a woman in love. That woman was Anne Druyan, creative director of the Golden Record Project, who would later become my wife. When she had her brainwaves recorded, she had just learned that we were in love with each other. So encoded on those records, now billions of miles away and traveling at 38,000 miles per hour, are the thoughts of a human being in the first flush of love. Whoever finds them, if anyone ever does, will know something true about us. These are our calling cards. They will outlast everything on Earth, because long after our civilization has crumbled, long after the sun has swelled and burned our planet to a cinder, those spacecraft will still be traveling between the stars, carrying our message to whoever or whatever might find them. That's not the behavior of an insignificant species. That's the behavior of creatures who know they matter even if they're small. In 2015, the LIGO Observatory detected gravitational waves for the first time, ripples in the fabric of space-time itself, caused by two black holes colliding a billion light years away. Einstein predicted these waves a century earlier, but we had never been able to detect them. The signal was so faint that the mirrors in the detector moved by less than 1/10,000th the diameter of a proton. Yet we built instruments precise enough to measure that unimaginably small displacement. We heard the universe ringing like a bell. We've imaged planets around other stars. The James Webb Space Telescope has photographed the atmospheres of worlds orbiting distant suns, detecting the chemical signatures of water, carbon dioxide, methane. We are beginning to search those atmospheres for biosignatures, the chemical fingerprints of life. Within your lifetime, we may know whether we are alone. We've peered back in time to the cosmic microwave background, the faint afterglow of the Big Bang, light that has been traveling toward us for nearly 14 billion years. When you look at that radiation, you're seeing the universe as it was just 380,000 years after it began, when it was hot and dense and glowing before stars or galaxies existed. We have photographs of our own creation, and we've done all of this in the last second of the cosmic year. What gets lost in the despair over our cosmic insignificance is the wonder of what we are. We are matter that has evolved to contemplate itself. We are star stuff, pondering the stars, organized assemblages of 10 billion 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 atoms, considering the evolution of atoms, tracing the long journey by which, here at least, consciousness arose. I am a collection of water, calcium, and organic molecules called by a particular name, and you are a collection of almost identical molecules with a different collective label. But is that all? Is there nothing in here but molecules? Some people find this idea somehow demeaning to human dignity. But for myself, I find it elevating that our universe permits the evolution of molecular machines as intricate and subtle as we. Look at the human brain, 100 billion neurons, each connected to thousands of others, forming trillions of connections, the most complex structure we know of in the entire cosmos. And that structure somehow gives rise to consciousness, to love, to art, to the very capacity to ask where we came from. How can that be demeaning? How can it be anything but magnificent? We may even be approaching a new kind of demotion, one Copernicus and Darwin never imagined. If artificial intelligence continues to develop, if machines begin to think and wonder and create, then human minds may not even be unique on Earth. We would share our planet with another form of intelligence, one we made, just as the stars made us. What does significance mean then? What does consciousness mean when it can be instantiated in silicon as well as carbon? Perhaps the demotion never ends. Perhaps every time we think we've found solid ground, the universe reveals another layer of our contingency. But perhaps that's the point. Perhaps significance was never about being central or unique or necessary. Perhaps it was always about being aware, being capable of wonder, being able to ask the question in the first place. The cosmos has produced in us its most extraordinary creation, not because we are large or old or central, but because we are aware. The atoms in your brain are engaged in contemplating their own existence. The star stuff that makes up your body is asking questions about stars. The universe has developed a way to know itself. We make our world significant by the courage of our questions and the depth of our answers. There's one more thing that needs to be said, because understanding our true place in the cosmos has profound implications for how we treat each other and our pale blue world. In 1990, I requested that the Voyager 1 spacecraft, then about 4 billion miles from Earth, turn its cameras around and take a picture of its home planet. Many at NASA thought this was a waste of time and resources. From that distance, Earth would be too small to show any detail, and we wouldn't learn anything scientific. But I wanted that picture for a different reason. I wanted us to see ourselves from far away and gain perspective. And when the image came back, it exceeded anything I had imagined. Earth was suspended in a beam of light, a mote of dust caught in a sunbeam, just a single pixel, pale and blue, against the immense blackness of space. Look again at that dot. That's here. That's home. That's us. On it, everyone you love, everyone you know, everyone you ever heard of, every human being who ever was, lived out their lives. The aggregate of our joy and suffering, thousands of confident religions, ideologies, and economic doctrines, every hunter and forager, every hero and coward, every creator and destroyer of civilization, every king and peasant, every young couple in love, every mother and father, hopeful child, inventor and explorer, every teacher of morals, every corrupt politician, every superstar, every supreme leader, every saint and sinner in the history of our species lived there, on a mote of dust, suspended in a sunbeam. The Earth is a very small stage in a vast cosmic arena. Think of the rivers of blood spilled by all those generals and emperors so that in glory and triumph they could become the momentary masters of a fraction of that dot. Think of the endless cruelties visited by the inhabitants of one corner of this pixel on the scarcely distinguishable inhabitants of some other corner. How frequent their misunderstandings, how eager they are to kill one another, how fervent their hatreds, all over a fraction of a dot. Our planet is a lonely speck in the great, enveloping cosmic dark. In our obscurity, in all this vastness, there is no hint that help will come from elsewhere to save us from ourselves. This is not cause for despair, but cause for responsibility. Astronomy has been called a humbling and character building experience, and there is perhaps no better demonstration of the folly of human conceits than this distant image of our tiny world. To me, it underscores our responsibility to deal more kindly with one another and to preserve and cherish the pale blue dot, the only home we've ever known. Think about that. In 100 billion galaxies, you will not find another Earth. You will not find another you. Every one of us is, in the cosmic perspective, precious. If a human disagrees with you, let him live. In 100 billion galaxies, you will not find another. The cosmos is vast beyond our most courageous imaginings, but rarity has its own value, and we are rare. Perhaps not unique, The numbers suggest otherwise, but rare enough that every human life, every thinking mind, every conscious moment represents something extraordinary. The universe grew us the way a tree grows fruit, and through us, it experiences itself. Through us, it asks questions, and that capacity to wonder, to question, to explore is precious beyond measure. Lost somewhere between immensity and eternity is our tiny planetary home. In a cosmic perspective, most human concerns seem insignificant, even petty. And yet our species is young and curious and brave and shows much promise. In the last few millennia, we have made the most astonishing and unexpected discoveries about the cosmos and our place within it. Explorations that are exhilarating to consider. They remind us that humans have evolved to wonder, that understanding is a joy, that knowledge is prerequisite to survival. I believe our future depends powerfully on how well we understand this cosmos in which we float like a mote of dust in the morning sky. We have lingered long enough on the shores of the cosmic ocean. We are ready at last to set sail for the stars. But we cannot set sail as conquerors, because we cannot carry into the cosmos the same hatreds, the same prejudices, the same narrow tribalisms that have caused so much suffering on this small world. The universe will not tolerate it. The distances are too great, the challenges too vast for anything less than our best selves. If we continue to accumulate only power and not wisdom, we will surely destroy ourselves. Our science has outpaced our ethics. We have the power to destroy our world several times over, but we have not yet developed the wisdom to live in peace with one another or in balance with the only planet that sustains us. This is the great test of our time. This is what the cosmos is waiting to see. Whether a species that evolved from the trees of Africa, that barely survived ice ages and plagues and wars, that has existed for only the last fraction of the cosmic year, can such a species grow up? Can we set aside our ancient enmities and work together? Can we become worthy of the stars? The significance of our lives and our fragile planet is then determined only by our own wisdom and courage. We are the custodians of life's meaning. We long for a parent to care for us, to forgive our errors, to save us from our childish mistakes. But knowledge is preferable to ignorance, and better by far to embrace the hard truth than a reassuring fable. If we crave some cosmic purpose, then let us find ourselves a worthy goal. The universe has been here for nearly 14 billion years. Human beings for perhaps 300,000. Civilization for 10,000. Science for 400. We are just beginning. What happens next depends on what we do here and now with our intelligence and our knowledge of the cosmos. We have a choice. We can enhance life and come to know the universe that made us, or we can squander our 15 billion year heritage in meaningless self destruction. That's what understanding our place in the universe really means. Not the despair of insignificance, not the arrogance of imagined centrality, but something far more interesting. We are the local embodiment of a cosmos grown to self awareness. We have begun to contemplate our origins, star stuff, pondering the stars. The cosmos gave rise to us, and through us developed a way to know itself. For small creatures such as we, the vastness is bearable only through love. That's the truth about our place in the universe. Not that we don't matter because we're small, not that we're the purpose of creation because we're conscious, but that we are the universe experiencing itself, and that in itself is extraordinary. The cosmos is all that is, or was, or ever will be, and our feeblest contemplations of the cosmos stir us. There is a tingling in the spine, a catch in the voice, a faint sensation as if a distant memory of falling from a height. We know we are approaching the greatest of mysteries. We are made of star stuff, and to the stars we shall return. Not as conquerors, but as children coming home. Not as masters of the universe, but as its most curious and wondering creation. That is our place. That is our privilege. That is our responsibility. And it is magnificent.